Good morning. We're going to look at a few more examples. Here we have sodium, question number 9, reacting with water to produce sodium hydroxide and hydrogen gas. If you look at sodium, sodium is a metal all by itself. It's reacting with water. Not exactly. We're going to be able to put water and we're going to make sodium hydroxide. Sodium plus my hydroxide ion, and it's going to create hydrogen gas, H2. So we need to look at how many of each element we have on both sides. So if I look at sodium, I only have one on that side. Then I have my hydrogen, and then I have my oxygen. So again, we're going to look at our reactants. We're also going to look at our products. We have hydrogen on that side, and we have hydrogen in two different parts on the other side. Hydrogen gas is another one of the diatomic molecules. Hydrogen doesn't like to be by itself. It has to be with something else. So, if we look at sodium, we have one sodium on this side. We have one sodium on that side. If we look at hydrogen, we have two hydrogens on the reactant side, but we have three hydrogens on this side. We know that on this side, the hydrogens always have to come in pairs of 2. So what's the closest multiple of 2 that's close to 3? 4. So since I know this always has to come in pairs of 2, but this comes in pairs of 1, I'm going to put a 2 in front of my sodium hydroxide. So now I'm taking 2 times 1 plus 1 times 2, and that's going to give you 4. And that's going to change how many sodium we have. If we go back here, we now have 2 sodium. And that means that on this side, I need to change the coefficient to 2. That sodium is all by itself. I'm going to put that part in front. So now we have the sodium balanced, 2 on each side. We have the hydrogens almost balanced. What do we need to put in front of the water to get 4 hydrogens? Put a 2 in front. The 2 times the 2 will give us 4. Now we need to look at the number of oxygens. On this side, we have 2 oxygens, because you have the 2 in front of this times the 1 oxygen. And then on the product side, we have 2 in front of this and 1 inside. So that's going to give us 2 on that side. So now we have it balanced, because we have 2 sodiums on both sides, we have 4 hydrogens on both sides, and we have 2 oxygens on both sides. Let's look at question number 10. Here we're putting together copper, Cu, and it says it combines with sulfur, which is S, to form copper 1 sulfide. What is the charge of sulfide on your periodic table? -2. So if I have copper 1 sulfide, that means I have to have 2 copper to balance out my 1 sulfur. Because this sulfur has a -2 charge, and they tell me that I want copper 1 sulfide, so I have to have 2 of the copper. So first we're going to list our metal, copper, and then sulfur. We have our reactants, and then we have our products. If I look at my reactants, I have 1 copper on this side, but I have 2 copper on my product side. So I need to put a coefficient of 2 in front of my copper to be able to balance out my copper. If I look at my sulfur, I have 1 on the reactant side, and I have 1 on my product side, so that is now balanced by adding a 2 in front of the copper. Let's look at question number 11. This is your final equation. 2 copper plus 1 sulfur going to Cu2S, where there were 2 coppers on both sides. Question number 11, silver nitrate. If you look at silver, what is the charge on silver? Silver has a +1 charge. If you look at nitrate, NO3, it has a -1 charge. So if I'm looking at silver nitrate, that would be my formula. And it's reacting with sulfuric acid. Sulfuric acid is taking sulfate with hydrogen, H2SO4. And it is producing silver sulfate. Now, sulfate had a -2 charge. We know that silver has a +1 charge, so I need to have 2 silvers to go with my sulfate. And then nitric acid is HNO3. Because nitrate has a -1 charge, hydrogen has a +1 charge. So now we need to balance our elements. We have silver, then we have nitrogen, sulfur, hydrogen, and then oxygen. If we look at our reactants, and our products, if I look at my silver, I only have 1 on the reactant side, but I have 2 on my product side. So that means right away I know I have to change the coefficient in front of silver nitrate to a 2. So now I have 2 silver, and I have 2 silver on this side. Next I'm going to look at nitrogen. If I have a 2 in front, and there's only 1 nitrogen inside, that means I have 2 nitrogen on that side. But over on this side, there's only 1 nitrogen in the nitric acid. So I need to change the coefficient in front of that to a 2. So now I have 2 nitrogen on that side. Now I want to look at the sulfur. If I look at sulfur on this side, I only have 1. If I look at my sulfur on this side, I have 1. So that's balanced. The next thing you need to look at is the hydrogen. On this side, you have 2 hydrogen atoms, 2 of them right there. And on this side, because we'd already put the coefficient 2 in front of the nitric acid, we also have 2 hydrogen atoms. If you look at this side, I'm taking 2 times 3 because there are 3 oxygens in each silver nitrate, but I have 2 of the silver nitrate ions, so I'm taking 2 times 3. But there's also oxygen over here on my sulfuric acid, so I have to add 4 to that. So if I take 6 plus 4, that's going to give me 10. So let's see if we have 10 on this side. I have 4 oxygens with my silver sulfate. And here I have 2 times 3 of the oxygens on my nitric acid. And that's going to give me 10. So now I have 10 oxygens on both sides. So I have it balanced by having 2 silver nitrates plus 1 sulfuric acid is going to 1 silver sulfate plus 2 nitric acid. Those are the examples I'm going to have you work on today. Have a great day.